Okay, let's carry on with some multithreading.
Right.
Volker asked you before or during the presentation how many of you had more than one CPU in your, or more than one core. What's the difference anyway?
I'm a software engineer. I don't do hardware. I think CPU is the physical package, core is the real CPU in there. And
yeah, hyper-threading, all that stuff. We just, when we say CPU throughout this, think hyper-thread, whatever you think that is important down there, something that can execute code independently of other things. This is not going to be a multi-threading class. Trust me, there is lots and lots of stuff to say about multi-threading. And I am not the one to teach you that stuff. Volker neither, I guess. This is going to teach you how to do multi-threading inside Qt, though. And Volker asked you, how many have 1, 2, 3, well, 1, 2, 4, 8 CPUs in your computer? And there was a bunch of people putting up their hands. They're getting more and more common, even on a cell phone today. There's phones out there with more than one gizmo in there that can run your code. There's actually 2 different use cases for multithreading. There's one use case where you take, and I'm just getting ahead of myself here, so let's go to the next one.
This one.
There's one use case where you just want your GUI thread to be responsive. So you have a GUI thread, and you know that if in a slot connected to a signal that got executed when you clicked on a button, whatever, if in that slot you were calculating Fibonacci numbers for the next 5 minutes, the whole user interface would not update. That is the most common use case for multithreading. That's the use case that we'll be talking about here. The other use case, which we'll not be talking about today, is the use case where you happen to be working at Google, and you have this really cool constraints that among trillions and billions of websites, you need to be able to find who matches, not just matches, but who matches the best a given query, like whatever. That's the use mode. Can you cut that out of the video? And if in that situation, you want to do things in parallel, not just to get stuff off your main thread, but really lots of stuff happening at the same time, just for the fun of it. And we're not going to cover that use case, just to see how bad we are off here. Can I see the hands of those who are working in a use case where you need to do lots of parallel computation? Okay, so that's less than 5% of the population in here. For you guys, you will definitely not want to go down the road of what we're going to talk about with QSweat and stuff like that, because that is going to be a lot of overhead. There is this new thing in Qt,
Qt Concurrent?
Qt Concurrent, that is written to focus exactly on that use case. And it is pretty new. It has some limitation, and we're not going to talk about that. But those of you who's interested in that, again, tonight at the party, corner me somewhere or corner Volker, and we can have a bit of talk about that.
Right.
This guy called Herb Sotter, how many of you know him? A few. He's writing in Dr. Dobbs' journal. He's working for Microsoft on their compiler division, something they like to do multi-threaded for some reason. He's written this article that is definitely worthwhile read, The Pillars of Concurrency, telling you about the basics of concurrency and why they're important. And he talks about these 3 pillars of concurrency. 2 of the pillars are what we already talked about, namely the pillar for just getting stuff off your GUI thread, the pillar for doing massive computation in parallel, and the final one is the correctness part. And gee, why do we want our applications to be correct all of a sudden? And that is actually a rather lengthy and interesting discussion. Of course, that involves something like you shouldn't be stepping on your own toes, so avoiding dirty writes and stuff like that. But there's a few other things in there.
Yep.
Multithreading is. I can continue on.
Well,
no problem.
I can do this as well.
Multithreading is it's an advanced topic, and we're not going to teach you about multithreading in this class. We'll mention it from time to time. We'll come up with what we at least believe is funny stories about multithreading, but be careful with multithreading. Ask yourself first and foremost, do I need multithreading in my application? Sure, I need multithreading. Well, are you ready to pay? If you're a project manager, it's easy. As soon as you add multithreading to the game, you will change days to weeks, weeks to months, months to years, years to, this estimate is never going to happen. OK, not that bad, but it's going to complicate things a lot. Suddenly, your good old debugger will not. Am I on? Oh. Your good old debugger is not. It's not going to help you, because as soon as you start the debugger, well, the problem will be gone. Anybody in here that done any multithreading will say, yeah, we know what that guy's talking about. Just warning those of you that hasn't done any multithreading, be careful. There's other ways that you can get around this.
Right. There's one thing like where you might think you need multithreading is animations, timers, anything that should happen after a specific amount of time. But unless it's really hard real-time requirements, and then Qt is probably not the best choice anyway. There's stuff like QTimer, QTimeline, we saw that earlier for animations, or even the more advanced animation framework, which takes care of that in a nice way without even requiring multithreading. It will just use the normal event loop and signal slot mechanisms that you have anyway in your GUI thread to inform you after a certain amount of time to do something, or to update your widgets or graphics items for animations.
Well, here's one thing you definitely need multithreading for. You definitely need multithreading if you have a TCP connection, because everybody knows they are blocking, right?
No. At least not if you use the Qt socket API. That also gives you signals when new data comes in, so you don't need to do a blocking read there. You can just wait for the signal that stuff comes in, and unless you need really a long time to process that, it's perfectly fine to do that in the main thread as well.
Yep.
Of course, this has a slight downside. You litter your code with lots of signal slot cascades to do this asynchronous code. If you write it just in a blocking way, it might be easier to read, but then you actually have to run that in a second thread so you don't block your UI.
Fortunately, if all you want to do is take a bit of work off your GUI thread and have that happen in a secondary thread, with the introduction in Qt 4 of signal slots among threads, a lot of the problems that you'll be using or be facing in other setup of multithreading is actually not going to bite you as hard. So if you can clearly distinction, this is something I kick off, it goes to another thread, the result is sent back as a signal to the first thread, or as we'll also see, is sent as an event from the worker thread to the GUI thread, then at least I've managed to get by without getting bitten too much.
Yep.
OK. With that warning, here's a few definitions.
Yeah, before we start, we need to at least know two different terms that show up in the Qt API documentation all over the place regarding use of those classes in threads. The first one is reentrant. That means you're allowed to use a method on two different instances of the same object simultaneously in two different threads. Now that sounds like obvious, so why would that break? Assume you are using a static variable in one of these methods, and you run that in these two in parallel. Even if you're on two different instances of the object, you still access the same static variable. If you use that for internal caching or something like that, it could easily mess up your job there. There was one such example in
There was one in the good old Q3 days that bit a lot of us. It was a QString has a method for formatting a string in the printf kind of way. So I think it's called format or sprintf or something like that. And that one was using a static char array for actually sending the result in. So if you try to do that on two different threads, it would it will screw you over.
Right. And even if you're doing that on 2 different instances of a Q string in 2 different threads, it would mess up. So that's the more surprising one. But actually, most of the stuff nowadays is reentrant and Qt. So you can safely use that in parallel as long as you're actually working on 2 different instances of that object. The stronger guarantee, that's the second one, thread safe. That means you're allowed to use the same method on the same instance of this object simultaneously in 2 different threads. And that obviously is much harder to guarantee, and it requires some safety mechanisms to protect the shared data to not be messed up by simultaneous writes on that data. And there's actually only very few methods in Qt that are actually thread safe. Most of them are actually related to multithreading itself, so you can use those to make larger elements of your application thread safe by protecting the not thread safe areas with them.
So an example of a thread safe method in Qt would be Q application or Q core application : post event, which obviously needs to put something into the event loop that you could do. You could access that from several places, so that's thread safe. But why didn't they just make it all thread safe?
Well, it comes with some cost to actually make that thread safe. You need protections, which we will see in a bit, mutexes and something like that to lock the common memory area, and that costs you some runtime. So they actually only made few methods thread safe, and if you need more of the stuff in a multi-threading context, you have to protect that yourself so that the performance doesn't hit you in the single-threaded case.
Exactly. Here's the overview again that we'll see from time to time. We didn't go into it when we saw it the first time, so let me just tell you what we're looking at here. In Qt, multi-threading, we have that introduction we've already been through. We'll talk about how do you actually kick off your threads. There's a few different ways to do that. Then we'll talk about how the thread communicates, and there is both signal slots that we already talked about, and there is posting events to other. How do they synchronize? And finally, there's a bit of a miscellaneous section in here. OK, so first thing, of course, we need to get a thread started somehow. The way threads are implemented in Qt is similar to what you might have seen in Java. You have a thread class, which you subclass. You re-implement a run method in there, and that's then actually run in your new thread. Yeah, you need to call start on it to actually make it start in a new thread, and then once the thread is created by the operating system, your run method is actually called in the new thread, and then you can do your expensive computations there without getting into the way. There are methods to wait for the thread to end, or to set its priority, which then, depending on the operating system, will influence the scheduling. And there's also one method in there to query what's the ideal thread count. So that helps you to find out how many CPU cores your system actually has, so how much stuff you can run in parallel without actually slowing it down instead of speeding it up. And that's quite useful, because finding that out in a platform-independent way is not that straightforward. So quite handy to have that. Okay. While preparing this presentation, you told me a short story I'm sure that people would appreciate here about set priority and our good old Windows platform.
Windows CE, yeah. The set priority stuff on sane modern operating systems, you rarely really notice the difference. The system needs to be on a high load, and even then it will still schedule the low priority stuff occasionally so that nothing starves there. However, there are some operating systems out there that are still supported by Qt. For example, Windows CE 5, that has a scheduler that is so primitive that it will starve its own operating system to death if you have a thread with the highest priority, which then will run all the time, and the operating system will never run again, and then your system is dead. So setting the priority on sane systems is perfectly fine. You will barely notice the difference. If you use a system that has a scheduler like the one on Windows CE, which looks like written by a first semester computer science student, then you might want to be careful with the priorities, because that actually can kill the entire system. But I'm not aware of anything but Windows CE that uses something as bad as this one anymore. Yeah, there's some more methods and signals on the thread to find out if it's still running or has completed its task yet. Both methods to query that, and signals that inform you when it's actually done. With something like is finished or is running, you of course need to be slightly careful, because they might change at any second. See, the task that's running is in the second thread, so that might finish at any time. So you might prefer the signals after over polling the is running or is finished methods. Yeah, and there's also methods to pause a thread without pausing the entire process, putting it to sleep if you need that for some reason.
OK, so that was a very low-level approach to multithreading. You will create your own threads. You'll override the run method and start executing them. And that is really very low-level stuff. You will have to create one thread for each CPU you have. We'll now move up a bit in abstraction here. So imagine that you had some work that could be split up into a number of work packages. So you'd have you might be generating thumbnails as an example. So a thumbnail generation is about, first you will read the file from disk, then you will be making a thumbnail out of it, and so on and so on. So in that situation, you have a number of work packages, and Qt has a facility for just running a number of threads for you, and then you can just say, go work on this job whenever you have a time for it. This is called a QThread pool. That's the class that represents the pool of threads. So you just have an instance of a QThread pool, and you will give it work to work on. And you do that by implementing this very simple class, a QRunnable. You'll override one virtual method, namely the run method. And that's where your code for that's to get executed will be located. You create an instance of that runnable that you have created and give all the parameters so it knows exactly how to work. You will give that to the QThread pool, and the QThread pool will eventually find a valid thread that is ready to do some work. It will execute that on that nice thread, and it'll be done. There is, of course, no idea in having, say 10 different thread pools, because they would all be competing for the same threads available. So you'd usually just have one or perhaps two thread pools. There is one magic thread pool called that you can get your hands on with the global instance. That's the static method of QThread pool. So if you just go and say, give me an instance, or give me that global thread pool, and then you'll put stuff onto that thread pool. As I said, this is not a multi-threading training, because there's many things in multi-threading, but there's just one thing that I'd like to point out in this context here, namely that if you have 256 CPUs in your machine, it's not going to be much fun generating thumbnails if you ask 256 threads to start reading data off your disk. So there, the I/O traffic is going to be your bottleneck. So that's a situation where you actually would like to create your own thread pool. So you have one thread pool that might have 2 or 3 threads available that you specify. This is for 3 threads. And that thread pool you put stuff into that needs to go to I/O. And then you'll use the global one for stuff that's pure computational. Of course, if your thread pool has, say, 10 threads, and you are executing on those 10 threads, and one of your runnables go to sleep because it's suddenly waiting for some data to come in over I/O, or logged in a mutex or something, then that whole thread in your computer will just not be working, and you won't get all the power out of your hardware with lots of threads available. You should, in general, be careful and not put anything that can block in any way into a QRunnable. If you really, really need to do that, then here is a bit of code that isn't that here?
No, you are one slide ahead.
I'm one slide ahead. No, I'm not. Where is it?
Oh, no, the wrong direction.
There we are. OK. Here's a bit of code for you to put into your code. It goes, it's that code up there. Longer arms. It is the thread pool : release thread. What that says to the thread pool is, I am now going to sleep. You can use this thread for something else. And then when you're done, you will call reserve thread, and your thread will be working again. Of course, that's not how it's going to be. I mean, it's not like we can take the whole thing off the thread and put something else on. But what technically will happen is that the QThread pool will start up yet another thread. So despite that the ideal thread count was 10, it is now running 11 because it knows that one of them has gone to sleep. And when you call the reserve thread again, it will start running, and one of those other 10 thread has completed. It will not allocate stuff on that thread pool again. Here's a note. It's easy to run into operating system limits when release thread is called too often. That is like if you have a limited amount of thread in some operating systems, then if you just call release thread on all of them, you might be running out of threads.
Well, in practice, I only hit that so far on Windows CE 5, where you really only have very limited amount of stack memory available for your threads. There you actually might hit that limit. But on modern desktop systems, the limit is so far up that you would need to run that in some infinite loop accidentally.
There are one bullet point I forgot on this slide here. Not important at all, I'm sure, but anyway, let's just go through it. It says here, there is no provision for canceling a task. Even worse, there is no for transferring thread exceptions. No, that's not the worst one. Here, for being informed when one of your runnables are done. QRunnable. I'm completely lost up here on my own slides. QRunnable did not inherit from QObject. So there is no signals that you can emit there. How would you do this? How would you tell everybody else that now your runnable is done? I mean, I ask for some stuff to be done. I want to know when it's done.
Right. That's actually what we will be seeing after the thread communication section. Because the way you ideally would do that is shown there. What we, however, can tell already is how it should not be done, and that is inheriting from QObject.
Oh yeah, that's because that is too expensive and stuff, right? Yeah, but no. I only have like at most 100 runnables in my system, so I don't care about the memory overhead. I will just I will have my runnable : public QObject, comma public QRunnable, right?
No. Let's have a look at the next section and see why that will horribly break.
Okay, I'm out of here then.
Yeah, so...
Don't do that at home, kids.
Right. Yeah, next section is thread communication, and that will also explain how we get results out of runnables. For that, we need to look a bit into the details on how QObject works in relation to threads. Each instance of a QObject is aware of the thread it belongs to. That's what's called thread affinity. So each object knows in which thread it was created, or its parent was created. So it usually inherits the thread of its parent object, unless you don't specify a parent, and then it's the thread in which you create that object that defines the object. the thread of that object. You can explicitly move objects into a different thread. There's a move to thread method for that. Well, so far so good. There's nothing really problematic in there yet. It gets nasty at the point where you realize that QSweat is a Q object.
You are getting ahead of yourself. First, we need to know, why are we into this game at all? And we are into this game of objects belonging to a thread. Because new in Qt 4, welcome to the world of Qt 4. That was only like 10 people that was in the world of Qt 3, but for those 10 people. Back then, it was not possible to have a signal slot connection across threads.
Right.
But now, in Qt 4, you can have an object, and the thread affinity means that an object lives on a given thread. So you have an object living on a thread. It emits a signal. That signal is executed in a slot on another thread. So if one object lives on thread A, another object lives on thread B, this object emits a signal on thread A. It will go and be processed in a slot on thread B.
Right, we are getting to that. No, you're ahead. So yeah, we have objects belonging to threads, and we'll see in a second why this is a problem with QSweat, which is an object itself, but it's actually belonging to the wrong thread because you create it in your main thread, for example, and it belongs to that thread, but not to the thread it actually represents. So why is that a problem? And now we are getting to what Jesper was talking about. Event processing happens in the thread the object belongs to. So if you send an event to an object, that is delivered to the object in the thread this object belongs to. So actually, each QSweat has its own event queue and can have its own event loop. So there's QSweat exec, which allows you to start an event loop in that thread. And that, of course, is something you need to do to trigger event processing in that thread. So if now a thread belongs to the wrong object, you might get your event delivered in the wrong thread, and the following task is executed in the wrong thread. But yeah, the real problem where this will hit you is when it comes to signal slot connections. Because the way they are implemented between threads is that they create an event that is posted in the event queue of the receiving thread. And yeah, if the receiving object belongs to the wrong thread, that is not executed where you would expect it. The API you might have seen already, that's the 5th argument to the connect statement, which allows you to specify the connection type. Usually in a single-threaded scenario, you have a direct connection. So if you emit a signal, that's like a direct method call to the receiving slot, right? But that obviously doesn't really work well if you call a method in a different thread, because you can't. It will execute in the thread you emit the signal. So we need to go through the event loop of the receiving thread. And for that, there's the argument queued connection, which means there will be an event queued in the event queue of the receiving thread, which, once it is processed, will actually call the slot. And that allows us to create safe signal slot connection between threads.
Before you get ahead here,
okay,
this is very important. Let's just review what he told us. I saw people almost falling asleep. An object belongs to a thread. Qt has a qthread : exec, which is just similar to the one that you have seen a million times, Q application : exec. It does this. reuse energy. No, that's not what it's about. It's a while true loop. Of course, it's not implemented as a while true, but nevertheless, it's a while true loop conceptually that runs around, picks out the next event of the event queue. So when Volker is, he can be a thread, and I'm a thread. He can send an event to me. And my event loop in my QThread, : exec, will pick that out and process it. And I know where to do that, or Qt knows where to do that, because me as an object is living or belonging to a given thread, and that's the thread where things will be executed. Now Volker told you the next information, the next important thing. Signal slot mechanism between threads. Volker can signal a slot. Bad joke. Volker can emit a signal which goes into a slot of another thread. The way he does that is he emits a signal. Qt will see, oh my god, these are living on different threads. It will take all the parameters to your signal. It will marshal it down. We'll see a bit more about that.
Yep.
It will put it into an event, a subclass of Q event. It will throw that to the other thread in its event loop, or in its event queue. That will unpack it again, and when it's unpacked, it will execute the slot associated.
Right.
And there's the important thing. And from the gaze in your eyes, I don't think that you realized how important what Volker told you there. In the past, you have grown into knowing and liking the fact that emitting a signal is nothing but executing the slot through a bit of pointer indirection. So if you have a line saying image foo with my data, that's an ampersand, in case you can't read that. You know that exactly at this line down here, where you are meeting the int brace, you know that everything is fine, because the address of the data that you gave was used in 20 different slots connected to you. But and when you are actually destructing your data, it wasn't a stack object here. When you're destructing it, all the slots will have been executed. Everything is fine. But as soon as you enter the land of signal slot connection among threads, this line here, all it'll do is marshal all those parameters here, put them into an object that goes into the event loop of another thread, and it's done. And at that point, you will all of a sudden be in trouble.
Right, because then you have a pointer to a no longer existing object somewhere in the event loop of the other thread waiting for execution. And when it's actually executed, well, you have an invalid pointer there, and you will most likely crash. So yeah, that's one of the important things to keep in mind. If you use cross-thread signal slots, you have some restrictions on the argument types. So pointers are obviously dangerous, especially if they are not living long enough. Well, you could use pointers, but then you need to make sure that it's only deleted after the thread has executed it, which is tricky. So yeah, the memory management is something to keep in mind there. Don't use anything temporary. Don't use anything that can't be safely copied into the other thread. Don't use anything that's, like even if it's a valid pointer that is written to by multiple threads without any kind of protection, because that's actually then memory that's used from two different threads.
There is something you can do. That Qt, the thing in red up there, you can just instead just write Qt : where is it? Blocking Qt connection. Why is that not in red? Qt : blocking Qt connection, emit. And it will be waiting here until the slot has executed in the other thread 3 days later, and it will, again, with the event system, send a message back saying, yeah, fine, I'm done. But of course, that's kind of pretty stupid. Why would you ever want to go and do that? you are emitting a signal from one thread to a slot on another thread just to be able to be multi-threaded, but now you're waiting for that other thing. That's the locking thing.
Right, and it gets even worse if the other thread does that as well. When calling you back, then you'll most likely run into a deadlock. So that's something that should be really used carefully, and only if you really, really need that.
Kids, don't try this at home.
Right. Yeah,
There's
that's
one thing first.
okay.
It's amazing how time flies, isn't it? If you all
Yeah.
look up on the wall there, it's beer time already. 6 o'clock.
Oh, we are done.
If you want to emit a signal to a slot, usual thing in regular desktop stuff, you can just emit a signal with a data type of my data, and it will make sure to copy data and get it to the other side. But it's slightly more complicated when you want to do that over a thread, because now in the regular non-threaded setup, it is just the method call with a bit of pointer indirection. So your C++ will take care of copying data whenever needed. But in the setup of signal slot, you need to help Qt marshal your data. So you need to help Qt make sure that your data can be put into a Q binary, I guess, and be unpacked on the other side.
Right. The key point is that you actually need to make a copy when sending it to the other thread, while with the direct call, you just, reinterpret cast wildly on void pointers. That's what it does internally, but you can't do that if you really need to create a copy. And that's what all of this stuff is about, helping Q to actually generically make a copy of your data. So
your data needs a few things. First of all, your class needs to be a copyable, is that even a word? Copyable class. It needs a copy constructor. It needs a constructor with any parameters, and it needs an assignment operator. And in addition to that, you need to register it with Qt, and you do that using this magic Q_declare_ meta type, my type. You just write that somewhere in where you are about to use it, so your header file seems to be a good place.
Usually in the header file, outside of any namespace, next to the declaration of the actual class, that's the best place.
And if you're one of those evil people that is doing stuff with static compiling and stuff, then that won't work. Then you instead need to write in your main.cpp somewhere or somewhere else. You need to explicit make this happening, and you do that using this Q register, meta type, my type, and parentheses open, parentheses close. Right. So this is the second restriction you have on arguments when connecting signal cross-thread signal slots. Volker.
Yeah.
I'd like to go back.
Yeah, we missed a few important things on the.
You said, and I don't. Why can't I just emit a signal? Why can't I just subclass and emit a signal?
From the runnable, right? So let me complete the missing bits in here. One missing bit is what happens with a signal slot connection if you don't explicitly specify if you use a queued or a direct connection. Then it falls back to auto connection, and that checks if the sender and the receiver are currently, at the moment where you do the connect, are in the same thread. Then you get a direct connection, and if not, you get a queued connection. So the problem.
How many of you like democracy? Okay, I like to try that democracy. You said that the auto connection will check the objects, which thread the sender object belongs to, and which thread the receiver object belongs to at connection time. I argue it's at signal emission time. Who votes for my version? Who votes for Volker's version? Dude, together with Volker, will you go and read the changelog for Qt 4.3? It is now checking at signal emission time.
So I'm
never mind.
4 versions behind. Oh my god, I'm getting old.
Gee, I would be fried tonight if that was not right, but I think it is. Anyway, go and check.
I will check that.
It is important indeed if you moved an object from one thread to the other.
Anyway, the best way around that is to explicitly mention that you want a queued connection. But there's the first thing already why the runnable subclass in QObject would be a problem, because you create the runnable. So
hang on a second. He's about to answer a question that I bluntly came with a statement before. Remember, we had the QRunnable. The QRunnable is the thing that you put onto your thread pool, and then it will just pick them up at random and start executing at a next free thread. And I said, heck, I will just subclass from QObject and emit a signal that will be then executed whenever I'm ready.
Right. But you create the runnables in your main thread, right?
Right.
And they are QObjects, so they belong to the main thread. So QSweat pool doesn't know anything about QObjects or QRunnables being QObjects, so it won't move it into the right thread. So all your runnables will still belong to the main thread. So if you emit from there, you will be, and you connected to that in the main thread, you will doing a direct call. And that means you will be calling code in your main thread, which is actually executed in the wrong thread then, and you will mess up all kinds of stuff. Worst case scenario, you're accessing UI, which will even crash your application.
Gotta try that at home. I'm sure that you will. You'll tell us another way to do that the right way then.
Right. So the general idea of using the same mechanism we have for signals and slots to also report back results from runnables is actually correct. We just can't use signal-slot connections directly. However, what we can use is QMetaObject invoke method. That is basically just send the event and call the slot part of the entire signal-slot thing without the signal. So what that allows us to use the same mechanism without having a sender that is a QObject. So QMetaObject invoke method is a static method, so I can call that from anywhere. And if I use that in run when I'm done, and do that on my main thread, it will detect that I'm in a different thread, and I will get the event posted into the event loop, and the same mechanism we saw before for cross-thread signal slots.
OK.
So you can use all this cool stuff, just not by inheriting from QObject.
Okie dokie. There is.
Do we have time for the QSweat being a QObject and actually?
Go ahead, knock yourself out.
Right, I briefly mentioned that earlier already. QSweat is a QObject, and you create that, say, in your main thread. So the thread object actually belongs to the wrong thread, and that becomes dangerous when you start to create object, say, in the constructor, or objects where you set the thread as parent object. Because then all those objects will also belong to the main thread and not the thread you're actually working in. And say you create a timer in the constructor of your QSweat, and you connect that to a slot in your thread.
Good.
Oh. OK. So the timer exists in the main thread. It will call the slot in the main thread because it uses a direct connection. So you're completely bypassing the thread you just created. OK, there we get the example code. So how you usually can work around that is considering, or not even thinking about QSweat as a QObject. Just consider main in the same way like you would implement, consider run the same way you would implement main. Create objects on the stack, because whenever you leave run, they will be destroyed and the entire thread will be destroyed, so that's fine. Don't specify this as a parent for objects you create there. And Since run is executed in the new thread, all the objects you create there without a parent will be created in the right object, in the right thread. And if you connect to those, it will automatically work. So yeah, that's the way you shouldn't do it. We have a thread subclass of QSweat, and in the constructor, we create a new QTimer. Even if that doesn't have a parent specified, the constructor is still, no, that's fine. The constructor is run in the thread where you create the thread, not in the thread you are creating. So this stuff needs to go into run, where it would work because we don't specify a parent. And only run actually runs in the new thread, and everything you create there is in that thread. That's something to keep in mind when working with QSweat and signal slot connections, because that can have funny results, calling code in the wrong thread, or worst case, even bypassing the entire thread you just created, and you don't get any of the benefits. Or you mix code being executed in the thread or in two different threads, accessing memory that you thought would only be accessed from one thread, and then you get crashes or all kind of undefined behavior.
Just to make sure you all, including me, understand this, I will make two fine circles here. This circle here, yep, this circle is my thread. My thread is a Q object, subclass. QThread, it's a subclass of QThread, which is a subclass of Q object. So my thread is living here. It's belonging to this fine class here. Down here, I have my QTimer. The timer is created on this thread, and I have a signal slot between the two. And that's exactly, correct me if I'm wrong.
Right.
This is exactly the problem. I thought that my slot would be executed over here on my new thread. It was not. It was executed on my GUI thread due to this.
Right. Because the timer is in, well, actually, the timer and the thread you're connecting to are both in the main thread. So this is a direct connection, and you will completely bypass the threading. If you now have one of these in the other thread, you get the queued connection, but it might still trigger code in the wrong thread.
And the way around this is, of course, to whatever objects that you want stuff to be executed on, implement that in the run method instead of in the constructor. OK, we are running out of time here for this slot. If we want some coffee at all before all the others take it, we'll have a break now. After the break, we will talk a bit about synchronization between threads, and then there will be a bit of time for questions for the multi-threading issues.
Right.
And when done with that, we'll continue on to ModelView. So see you all again in 15 minutes.